we're going to go into analyze, and then we're going to go into compare means, and then one-way ANOVA. And what I did here is I just right-clicked and then display variable names just to make it a little bit simpler here. All right, so the dependent variable we know is weight loss, and then our independent variable is the diet. Before I do that, I made a mistake here. I need to show you this. So we have 3 conditions to the diet here. You got to check this data and just to see these 3 conditions to the diet. So if I'm to toggle this, I'll see the very 3 conditions. Condition 1 is diet pill condition. Condition 2 is placebo pill. And condition 3 is diet pill plus exercise. Variable view, you can sort of just verify this right here. So if you look at the diet condition, you have these 3 conditions right here, and they've been designated for you, and then it's a nominal, right? It's not on scale, it's nominal. And then our weight loss condition is on scale, so it's continuous. So let me get back into this. So we got this again. Weight loss goes into dependent variable, and then diet goes into the factor list. We're going to go into here, and we're going to get the homogeneity variance. An options window, that's homogeneity variance. Next thing that we need to do, let's see here. We don't need any of this right now. That's going to be a little bit later. We're just going to do that for right now and then press OK. The homogeneity variance is going to be the Levene's test. And as we see here, we want to have a p-value that is not statistically significant. What I mean by that is a p-value is greater than 0.05, right? So the p-value has to be something greater than or equal to 0.05. What we have here are values that are greater than 0.05. We would look at this based on the mean, I believe. And so that's our Levene's test. That is homogeneity of variance. So that was the third assumption that we saw there. So that has been met. Let's go ahead and move on, because now we have that assumption being met. Let's go ahead and go to the next assumption. Okay, so I probably should mention that before we go into the other assumptions, we need to answer this question. So we have this homogeneity of variance assumption here. If I can type. Was not violated because, as we see here, I'm just going to move this down over here. Because the Levene's test p-value was less than, or actually greater than 0.05. So we have a non-significant p-value. P equals 0.114. So I guess, yeah, another way of saying this is we have a non-significant p-value, which is indicating that this assumption has not been violated. All right, yeah, so there you go. I think that pretty much settles that one. Let's move on to the next area. So we're gonna independence has not been violated because, well, why is that? If we go right here, to go right here and just think, you know, we just copy and paste that for right now, but it was written in this description right here. So as you can see here, it's written right here, and for this lab, just assume that we got a random sample and it's independent. Now we just write because whatever the walkthrough says right here. That's what we got. We got this one. We got it. All right, so let's move on to B. Now we have to look at normality. That's going to be a big thing because we haven't done this before in lab. Let's see here. Let's go into this area. What we're going to do in order to test for normality, whether the assumption has been violated, we're going to go into Analyze, and then we're going to go into Descriptives, and this time Explore. So essentially what we're going to be doing is looking at the distributions and seeing if these distributions are approximately normal. Now I need to put diet into the factor list. This is the independent variable list, and then I put dependent variable dependent list weight loss. This is what we're measuring, and this is what we're changing in the experiment. This is the manipulation, and this is the outcome measure. We're going to check on outliers because outliers indicate, give us an idea whether or not we have a normal distribution. At least gives us some clues. Plots also is going to be something we're going to look at, normality plots. So I'm going to check that off. I don't think we need to check off this histogram. We'll check this one off because this is interesting. Look at the stem and leaf plot. Press OK. And it's going to take just a little bit to process. There we go. I'm going to move this out a little bit. Actually, we'll just scrunch it back up again. All right, so what do we have here? What we see is a nice table telling us how many participants we have in each group. And we have 25 in the diet pill group, 28 in the placebo pill group, and 28 in the diet pill plus exercise group. Now, in the diet pill group, here are the descriptives. What are we looking for when it comes to normality? Remember back to the first or second week, I think we were talking about these two, skewness and kurtosis. So we want to have a skewness that is between -2 and +2. So you want to have values between those to have approximately normal distribution. And you also want kurtosis to be between -1 and +1. And it looks like here that the kurtosis has been violated here in this example. Right, so yeah, so it should be -1 and +1 for skewness. Let me correct that. And then -2, between -2 and +2 for kurtosis. So we do have a kurtosis violation here because it exceeds +2. So we want to have something between -2 and +2, and we have something that exceeds +2 in this direction. So this is a violation. We'll have to take note of that, and we could write it right here and say something about it. But let's move on before we go into report section. So placebo pill, let's look at their skewness and kurtosis for this group. And it looks like it's between -1 and +1 here. And the kurtosis looks like it is between -1 and +1 as well. And then the third group, diet pill and exercise, -1 and +1 for skewness, and then between -2 and +2 for kurtosis. So right off the bat, we could say the assumption of normality has been violated. Or one indication is the diet pill group's kurtosis exceeds the boundaries for an approximately normal distribution. All right, so in that case, maybe you can just give the value. So kurtosis equals 2.4 in that. I think that's what it was. We'll say 2.5. So that's one indication, but we want to look at multiple indications. I think that's very important. We're not really purists in this sense. I think that as long as other things are consistent, then this is kind of a minor concern. But then we have this test of normality that needs to be less than 0.05 for each group, or greater than 0.05. So there needs to be a non-significant, this is a test of non-significance, and we're looking at K and S and W. So in particular, we'll look at Shapiro-Wilk. And what we see here is diet pill. It is a non-significant p-value, and then we see placebo pill, non-significant p-value. But what about diet pill and exercise? This is significant p-value. So this is a major violation. So Shapiro-Wilk's test reveals that the third group has a significant p-value, right? And I guess this is redundant. I'm just going to write it as this, but there's probably a less redundant way of writing this. All right. This is indicative of violation of normality. Okay, so that's that right there. So we have another indicator, and I think this is more of a major indicator there of violation of normality. Let's move on to the next part. Now we're going to go into normality plots, and we want the data to be approximately next to this best fit line right here. And if they're way over here or way down here, then we know that it's not approximately normal. If the expected values and the observed values are so different from each other, then it's an estimation of non-normality. So in this case, we're looking at diet pill. In this case, we're looking at placebo pill. It looks like they're towing that line pretty well. In this case, we see diet pill plus exercise. And notice here, it does